Okay, so today we're doing a video on how to set up, install PfSense in your network. We're going to cover a few topics just as far as getting the public IP addressing set up on your firewall, getting the LAN side interface set up, some DHCP, some basic rules from a security standpoint, allowing and blocking various traffic types, and we'll look at some of the visibility, some of the reporting that you have available that PfSense firewall brings to you. So the beauty of PfSense is that it's open source, aka it's free, it's supported by a community, it's updated heavily, so you're getting the latest in from a security standpoint. It's trusted. There's a lot of businesses and organizations that use it, as well as a lot of home enthusiasts that want greater control and visibility into their network. So it installs on a wide range of hardware. You don't have to buy their specific hardware. You can install it on an old desktop, an old server, whatever you have. The one thing you must have is you must have a device that has two interfaces, right? One for the internet and one for the local area network side. We're not going to cover that too much today. There's an assumption here that you understand what a firewall, what a router does for you, how to get a public IP address from your service provider or multiple public IP addresses depending on what you're trying to accomplish. This is really just going into the setting up of the software itself. You know, you can buy these small devices directly from Nextgate, through PfSense, but as I use here, I have my own device with two network cards, and that gets me everything I need to do from a control standpoint. It doesn't require a lot of horsepower, so you can use a pretty old desktop. Something that doesn't consume a lot of power is ideal. Something that boots off a USB drive is ideal as well too. So I'm going to kind of talk through my setup here a little bit just to set the stage, let you know what I got going on here. From a PfSense standpoint, how my setup looks. We're going to go ahead and bring up a pencil here. So pretty straightforward. What I'm sure a lot of you are looking down is I have cable internet. So I have my coax cable coming into my house. I have a cable modem supplied by my ISP that converts that internet into a Ethernet, right? So then I have an Ethernet cable coming out of my cable modem, and then I have my PfSense firewall sitting right here. PfSense. So that cable from my cable modem, the Cat6, goes to my WAN interface of my PfSense firewall. And then on the LAN side, I have a switch for cooking up all the various devices in my network. And then, of course, back here I have my desktops, my end users, my iPads, my tablets, right? I have some wireless back here to create my wireless network. And all the traffic on my local network has to go through PfSense in order to get out to the internet. And I have rules that control what can get in and out, and then anybody coming in from the internet, I also have rules created to determine what traffic to allow and not allow. So pretty straightforward setup. It does help that I have a static IP here on my WAN interface. I actually have multiple static IP addresses, so in some of my future videos I'll show you how to set up virtual IPs and how to static NAT a public to an internal device for things like open gaming on Xbox and PS4s, and setting up Plex servers or whatever you want to do in your network, and how to use those. You don't have to have a static IP address from your service provider for this to work. PfSense can do DHCP on the WAN side, so not a big deal. You just have to be getting an internet IP address on this side for PfSense to function properly. You don't want to be doing a router behind a router, right, and creating all sorts of complexity. So pretty straightforward setup. I'm guessing this is something you're progressing down as well too when you're setting up your PfSense. So I have a server built ready to go. I actually have a virtual console open to it. So I'm going to boot the PfSense ISO from scratch. And let me find the PfSense. So you just go to the download page here at pfsense.org. I'm doing an installation, not an upgrade. I want the 64-bit architecture because I'm using 64-bit hardware. If you're using really old hardware that doesn't support 64-bit, grab the 32-bit ISO, and then I usually grab the CD ISO installer, and then you hit download. And when you do download it, you're given an iso.gz file, gzip file. You'll have to use WinZip or WinRAR to extract it and actually get your ISO file. And then, you know, take that ISO file and boot. You need to boot the device that you're installing PfSense off that ISO, kind of like installing Windows. You can do that from a CD, so you can go out and grab like image burn and burn that ISO to an actual CD. If the device you want to do boot from USB, grab something like Rufus and Rufus will take that ISO and actually turn it and take your USB drive, get a little thumb drive, and create a bootable USB drive, and then get your device to boot off that USB drive. Again, from a PfSense hardware standpoint, you don't need much. 32 gig SSDs are so cheap, right? I would probably, if I had the choice, I would throw a 32 gig SSD inside an old computer and install PfSense to that to give you a fast local drive. If you want to do advanced things like caching or advanced reporting savings, you'll be glad you'll have a disk in there that can handle that sort of thrashing. If you're just going to typically use this as a firewall only with the router, you're not going to need, there's not going to be a lot of disk transactions. It's all going to be sort of in memory and in real time. So once you have your, say, call it your CD and the CD-ROM drive, and you boot the computer, this is the stage I'm at, so I'm going to go ahead and boot this computer. It's booting off the PfSense ISO. As you see here, you're brought to an initial boot screen that has some options for booting. By default, for installation, just let that 10-second timer run down, and it'll boot you into the installer. And you should have a monitor and keyboard hooked up to get through this installation, and you'll start seeing the text scroll by from the initialization, from it determining what type of hardware you have. Here's another pause screen in case you ever have an issue, kind of like booting into a recovery mode. Again, it's got a 10-second timer. Just let it continue. Installer will launch automatically if you don't do anything, or you can hit enter if you're ready to go and you're tired of the countdown. Okay, so we're continuing to boot up here. It's going to bring you into configuring the console. If you can see this screen, that's a good thing. Then the video font and screen map is probably working. If you can hit the up-down arrows on your keyboard, then your key map is probably working successfully. You detected it, so you can just go ahead and accept these settings. I'm going to go ahead and go to the custom install because I want to make sure I pick which hard drive it gets installed to. If you're installing from a bootable USB onto a USB in another port, custom install would make sure it's hitting the right drive successfully. So let's just go through custom install. So custom install, the first question you get is what disk do you want to install PfSense? And if for those of you that are savvy know that I'm doing this in VMware, and that I have a VMware virtual disk assigned. I assigned an 8 gig disk. This could be an 8 gig USB drive, an 8 gigs drive inside the computer itself. But again, it's nice because it lets me select which drive I want to install it on before I continue. So we're going to go ahead and pick that. Do I want to format this disk? Ideally, it's a disk, right? If there's any data on it you need, I would not suggest installing onto it. I would get that data off. But I'm going to go ahead and yes, format this disk so it's nice and fresh. Now here I do just accept the defaults. I'm not, even though the advanced install has these, you don't want to change the cylinder's head and sectors on your hard drive. So we're just going to select use this geometry, and it's giving us our final confirmation of, are you sure we're going to format this disk and erase all data that lives on it? And I'm okay with that since it's a new disk. And then we want it to partition the disk. Its default settings are fine, so I'm going to go ahead and use the down arrow key to go to accept and create. And yes, partition it, and it'll tell us it was successfully partitioned. And then boot blocks. Do you want to accept and install boot blocks? Yes, we do. It's the boot manager. When the computer boots up, it's looking for boot blocks or some bootable information telling the computer what to boot off of. So we're going to install that. And OK. And install it on that partition. And again, we get a confirmation. Are you sure? All the data will be irrevocably erased when we select OK. OK, it was formatted. We're going to accept and create these sub-partitions. And it's creating those. It's a lot of effort, right? You could do the quick install if you're more comfortable with that. The only reason I wanted to come into the advanced install was to select the drive so that you could see that. Maybe you have multiple drives inside the system. Maybe you've plugged in multiple USB drives. So the high level there is the only screen we really care about in there is the choosing of the drive to install to. After that, we're just accepting all the defaults for partitioning, for sectoring the drive, a bunch of stuff where the quick install would be a lot more handy. Seems to be there needs to be like a middle install, because if you do quick install, it does not allow you to choose which drive to install it on, which I don't like. I like seeing the drive. Unfortunately, advanced install takes you through all those other steps, but it's worth hitting the enter key 20 times just to make sure you get the right drive. So pretty straightforward. Now we're at the hurry up and wait screen. Depending on your computer age and the media you're installing from, this will take anywhere from 2 minutes to 5 minutes. It's not a lot of it's not a lengthy installation, but you are going to have to sit here and wait and take a break and let this install. But while you're waiting for this install, now might be a good time to determine what type of IP addresses you want to use on your local area network. So as you know, internal IP ranges, Google's your friend. I did a quick search for internal IP address ranges, and I get this nice rich card here that says, here are the IP addresses I can use for my internal network. If you're on an existing device today by Linksys or provided by your ISP, and if you do an IP config, you probably have 192.168 addresses on your local network. And but there are other ranges you can use. 192.168.1. whatever is the most common, with a 255.255.255 subnet. If you don't know what I'm talking about, you might want to look into it, because it is important to understand the network. If you do an IP config from your Windows device, you can see what your IP address, subnet mask, and default gateway is. So IP address, my computer that I'm on has pulled a 172.16.1.100 address. It's using this subnet. All my devices on my network have the same subnet. And then the default gateway, which is actually the PfSense firewall on my network now, has this IP address. So you're going to have to pick one of those IP addresses in that range to use for PfSense, and all the other IP addresses in that range are going to be used by the devices. So my range in this scenario is, let's bring up a notepad here. My current IP address is 172.16.1.1 through 172.16.1.126. It is not uncommon. It is most common to put your firewall on the low end, the first IP address in that range. And I use a subnet of 255.255.255.128. For those that are good at math, know that there's a possibility to put 125 hosts on this network between 1 and 126 with this subnet, and then this is your gateway. This is your gateway or firewall. This tells your devices where to send all their traffic. For this lab scenario, we're actually going to use 192.168.1.1 through 192.168.1.254. We're going to use a subnet of 255.255.0, and we're going to put the PfSense firewall on 1.1. This is important because we're going to set up DHCP as part of this video. So outside of the PfSense firewall getting us configuring this IP address, we're going to set up our devices on our network to use IP addresses from, say, 100 through 254. We have 253 addresses available here, 254 addresses, so it should support any home network, no matter, if you have more than 254 devices on your home network. It's more than a home network. So this will be good for many of you. All right, let's see hard. So you now may wish to install custom kernel configuration. We don't. We're going to go with the standard kernel from our PfSense standpoint, and this is where now it's actually extracting the operating system and its software from the ISO to the local hard drive that we selected to install it. Again, this just takes a couple of minutes, and then we'll be able to access our PfSense firewall and start with the configuration. Okay, it's done. So the machine is about to be shut down. It's asking you to reboot. I would remove the CD or USB stick, whatever you're installing from your computer at this point. Otherwise, it'll automatically boot back into that installer drive. So we're going to go ahead and hit reboot on this. And I'm going to go ahead and pull the CD drive away from this. Okay. So I've effectively ejected the CD on my side. So now when this boots up, it's going to boot up to PfSense. It does take a minute. Yes. Sorry, that's just on my end. You won't get that. Okay. It's going through its shutdown tasks. And now your computer should be rebooting. A little bit different screen. You can boot to PfSense, press F1. You don't have to hit anything here. It will continue automatically after 10 seconds. As you can see there, I didn't hit a key, and now we're getting a spinning wheel. Again, another boot message that advances after 3 seconds. If you're troubleshooting, you have all these little hooks to be able to stop the boot up process and see what's going on. But now our PfSense is actually booting up. As you'll be able to see here, it boots up very quickly, bringing up our interfaces. Okay, so as you can see now here in the text screen, this is a very bit of important. Before you walk off and head back to your computer, you need to see two very important pieces of information. And you can see it automatically assigns, when you have two interfaces in your device, it automatically takes the first one, EM0, and makes it the WAN interface and uses DHCP in order to pull an IP address. So it actually pulled this IP address from my service provider, which, as you can see, is an internal IP address. So you have to be very careful, right? You want to see a public IP address on the WAN interface. On the LAN side, EM1, which is the second interface it finds based on where you have them installed in your computer. If you have an onboard NIC, it's probably EM0, and then if you have a PCI card NIC for your second NIC, it's going to get EM1. So you can test it that way. A good way of troubleshooting is actually pulling one of the cables out so that the interface goes down, and then look at the command prompt here, and it should give you an alert as to which interface it saw goes down. By default, it uses what we're going to use. It uses 192.168.1.1 with a /24 subnet on the LAN side. So for those that need DHCP up to their cable modem, this is fantastic. It should pull your public IP address, and you'll be good to go. For those that don't or have a static IP address, they'll have to come in and configure this WAN interface. But as long as we have our LAN interface, we should now be able to access the device. So let's go ahead and bring up our browser and test that out. Okay, so now that we think this is up, your first test is to go ahead and bring up your trusty command prompt, and you should, if things are communicating correctly, you should be able to ping the LAN interface on the PfSense firewall. So we're going to go ahead and throw a ping on that, and that tells us we are good to go. If you want to use a different inside IP address, now is a good time to change that. You actually go into hit option number 2 here to set interface IP addresses, and you can walk through. You can see that our WAN interface is set to static, or excuse me, DHCP, to pull an IP address from our service provider automatically, and the LAN interface is set to static because you have to define what IP address you want to use on your LAN. So you could go into LAN and you could change that IP address to 192.168. Maybe you want to use 192.168.50.1, or maybe you want to use a 172. So we're going to go ahead and just 192.168.1.1. We're going to keep it the same. We're going to use the 24-bit subnet mask for 255.255.255.0, and this is for a WAN. Enter the gateway. For a LAN, press enter, because we are the gateway on the LAN. We're not using IPv6. And do you want to enable DHCP server on the LAN? You do, because you want it to automatically give out IP addresses to your devices on the network. And we're going to use 192.168.1.100 through 1.150. And this is up to you. Do you want to use HTTP or HTTPS? I'm going to leave it with HTTP for now. And now we've reconfigured the LAN side interface with our IP addresses and our DHCP, and we're pressing enter to continue. And if you look now, our IP address on the LAN side is still the same, but if you're having issues, if you're not able to ping it, I would maybe walk through that again. Fixing the IP address, making sure DHCP is enabled, that way it automatically gives your computer an IP address, and the net is you should be able to ping that LAN side interface if everything is going well. Another way to test that, of course, if it's going well, is we're going to go ahead and go to the web address. And lo and behold, there's our PfSense web configuration page. So at this point, if you can get to it, you're pretty much done with the console. You can make any additional tweaks or changes you want in the PfSense interface. So we're going to go ahead and get rid of this guy. The default username is admin. The default password, I think, is password. Nope. The default username is admin. The default password is PfSense. So let's clarify that. The username is admin. The password is PfSense, all lowercase. If everyone can see that. Okay. And it brings you right into a setup wizard. So this wizard will provide guidance through the initial configuration. We're going to go ahead and hit next on that. You can sign up for a gold subscription and pay for gold support from PfSense, which could be handy if you're running in a business standpoint. So the first thing we need to do is give our device a host name. By default, the host name, right, this is the name of the computer that's running on, is defaulted to PfSense. That's perfectly fine. You call it my PfSense. The domain, leave for local domain. That's for advanced configuration if you have an Active Directory or authentication domain in your environment. So we're just going to leave it at local domain. And then we're going to leave our DNS servers blank because it will actually pull those from our service provider automatically. It's got a default time server. It's best practice to make sure your firewall is set to the right time. So when you're looking at logs and things like that, it's accurate. By default, it uses a PfSense time server. That's fine. I'm a fan of pool. If you go to NTP time server pool, you can find pool.ntp.org. That way you're not reliant on PfSense's time server being up. You have a pool, and then set your local time zone. I am GMT -5 where I'm at. Now, this is where it gets important, and you should make note. Right now, it's asking you to configure that WAN interface. So the device that's connected up to your service provider's modem or DSL modem, whatever the case may be, this is where you get a chance to say, yes, I'm okay with it set to DHCP, automatically pull an IP address. For most people, that's going to be the ideal configuration. The cable modem is going to give you a public IP address via DHCP. So you can just leave this at DHCP and ignore everything else below this because you have PPTP configurations, PPoE configurations, static IP configurations. This is only if you know what you're doing. DHCP for most. I do have a static IP address, right? If you noticed in my setup, I was given an internal IP address by my service provider. I had to request a static IP address, and they gave me one. And it is 50.90.3.174 with a 29 subnet mask. And the upstream gateway is 50.93.170. Okay, so if you have this information from your service provider, fill it out. If you have a DHCP address, don't take that address and put it into the static field, because when your cable modem reboots or the DHCP lease expires on that address, your service provider may give you a new one. So if you truly have DHCP, leave it as DHCP. If you have static, put that information in here. And everything else by default can be left the same. And then again, it's having you confirm your LAN address. We configured it via command line. If you want to change that or tweak it, you can here. We're using 1.1 DHCP. And here's where, of course, you reset your admin password from the default PfSense. Pick a secure password and remember it so you can get back into your device. And that's it. Once you have the configuration complete, it's going to ask you to reload. Then it's going to reload your configuration. It'll let you know when it's complete. And that's it. Congratulations, your PfSense is now configured. Click here to continue to the PfSense web configurator. And this is an initial look at what PfSense gives you from a visibility standpoint. This is the dashboard. You can always get back to it by clicking the PfSense logo here in the upper right-hand corner. You see there's my host name that I set up. Here's the current date and time and release number. My DNS servers that I pulled from my service provider automatically. A couple things to keep an eye on here are the CPU utilization. Depending on what kind of hardware you're using, you may want to see how hard this box is working to serve internet. You have memory usage to see if the box you're using, I've given mine 1 gig of memory. As you can see, it's only using 17% of that. PfSense does not use a lot of memory, and it's only using 500 megs or so. So that is your requirement from a disk. So pretty good information here on the system information. You can use a little minus up here to collapse it, a little plus sign to bring it back out. And then here's a reminder of your interfaces and what IP addresses you have set on your interfaces. There is a little plus button here where you can add in additional widgets for what you want to see. I like seeing the traffic graph so that you can see from your dashboard the traffic coming in and out of your environment. So I bring in plus the traffic graph. I go into the settings and I refresh this every 5 seconds. And of course, as you can see, since we just got this set up, there's not a lot going on. There's some other useful widgets in here depending on what you do with the device. You may want to have your logs up here, your NTP status, what packages you have installed. You can put a picture in here. If it's able to hook into the thermal sensors of your device, you can pull that up to see how hot your device is running. But this is the good one here. So the things we've configured already are under, if you look under interfaces, you have LAN and WAN. If you mess something up or want to change something, you can come back into interfaces WAN, and here's where you see where we've enabled the interface. We're using a static IP address. We've set the IP address. If you need to go back to DHCP, you can do that here. If you're on DHCP and then your ISP allocates you your statics, you can come in here and change that. And then same thing on the LAN interfaces. You can see all our LAN interfaces setting. Maybe you decide you don't want to use 192.168.1.1, you want to use something else. You can come in here. Anytime you make a change, don't forget there's a save button at the bottom of the page. You have to hit save. And then at the top of the page, you get an apply button. Just because you saved them doesn't mean they're applied. You come to the top and hit apply. Now your changes are applied. So if you change something, you see that, what did I change? I lost access to it. There we go. So the page just kind of refreshed there. Okay, so that's under interfaces, right? You have this already configured, but this is where you make any changes. Let's see here. Let's find under services. One of the things we set up already is we set up our DHCP server. So you want to come in here, and you see that we enable DHCP. We did this via the command line, but if you want to change that, you see for the range here, it's using 192.168.10 through 245. I want to change that to 100 through 150. And we're good with that. And we're going to hit save. And these changes have already been applied successfully, so we can close that. So this is your DHCP. These are the addresses that are given out to your devices on your network. Unless you have something else doing this or want to use static IP addresses for everything, enable this and pick a range here within your subnets. You don't want to use the full .1 through .254 because, as you know, the firewall is using .1 and you can't have conflicting IP addresses. So at worst case or best case, you can go from 2 to 254. And that would take care of all the other IP addresses in your range. Here's some advanced settings. If you want to push down specific DNS servers to any of those clients, a specific gateway, specific domain name, these are typically advanced settings that you don't need to use unless you know what you're doing. By default, it'll give out these IP addresses and it'll pass along the DNS servers from your service provider. And this is where it gets interesting, right? So if you look at under the firewall, so system has a lot of system. We can go back through that wizard. We can check for updates. You know, we can look at the advanced configuration, which there isn't much you should have to change here, other than you may want to change the protocol to HTTPS on your web configurator. I don't really care because I'm not allowing, you don't configure the firewall from the internet. You don't allow people to connect to the firewall's web configuration page from the public internet. So I'm just on my local network, so the fact that I'm using HTTP, I don't really care. But rules are the fun one. So you have two sets of rules when you come into firewall rules. You have your WAN side rules and you have your LAN side rules. Think of it like this. On the WAN side is what I'm allowing into my network from the internet. And as you can see here, there's some specific default rules that are created by PfSense. I would leave those alone. The default rule for inbound WAN connections is to block. So by default, everything trying to get in on the internet is blocked. I'm a stickler. It's not clear to me in these rules that it's blocked by default. So I do like to add a rule at the bottom that says block on the WAN interface. All traffic, leave it as any. What I did here is at the bottom, I created a rule that says any IP4 TCP, right? I'm going to actually change this to TCP, and I'm going to change this to any, because I made a little misclick there. As you can see now, I am blocking all IPv4 traffic from any source to any destination on my network, to any port, to any protocol. Block it. And then I save that and I apply those changes. Now here's a good trick, is that when you come into this edit of these rules, there's a button down here that says to log the packets handled by these rules. If you come into status and go to system logs and then go to firewall and dynamic views, you can see here all these log entries, all these blocks that are coming into my network, right, that are trying to access this device. If you want to see all those entries, then when you're in your firewall rules, you need to check that little box that says log these packets that are handled by these rules. And for my description, this is called block all. Okay, so now we have this icon here, right? If you notice that we have these little 3 black bars here on our rule set that says traffic is being logged. So in order to see the rules in order to see the activity in the system log, you have to make sure you come into your rules and log packets that are handled by this rules. The reason you can turn it off is because once you're done troubleshooting, or once you have your setup baked in, you may not want to fill up your log files with all this information. But we're going to go ahead and apply those changes. And now if I come to my system logs and go back to firewall, I like using the dynamic view. We can run a filter on destination IP address, and we can put our public IP address, which was 5093.174. We can put our IP address in here and apply the filter and look at, just out of the gate, right? We just have been booted up for what, about 2 minutes, and we can already see that there's source IP addresses on the internet scanning the public IP addresses for open ports. 23 is a common one. People are looking for open SSH servers. You'll see those all day long, right? I don't know where 88. What's interesting is you can take this IP address and do a reverse lookup on 88, 87, 92, 144. Reverse IP lookup. Okay, let's just do an IP lookup. There we go. And we see that this is coming out of Russia. So here's Putin, one of his hackers, continually scanning all IP addresses, SSHs, for servers they might be able to hack. If you don't know what port, 7547, you can do a port. What port, let's not do this in our PfSense, what port is 7547? CPE WAN management protocol. Hey, so they're looking for open ports on routers and configuration devices. So when you hit dynamic view, this will automatically refresh, but you can always apply filter, and you can just have fun watching this list grow and grow for people looking for open ports on your network. This is why it's important to have a firewall and understand, because if you don't have a firewall, these ports are potentially getting passed through to a device on your network. If you had a computer plugged into your cable modem using this IP address, it would constantly be getting scanned for any open ports or any way for someone malicious to access that IP address. So that's the importance of coming into your firewall rules and turning on logging. 1, so you can see what's going on, and 2, for when you're troubleshooting. If you are trying to allow certain traffic into your network, you can actually come into those logs and see what's getting blocked and what's getting allowed through, so that you can make sure your setup is correct. So I do put the default block all rule here at the bottom so that I can log it, because by default you're blocking it and not logging it. Then on your LAN side's different. On the LAN side, you'll notice that everything by default is allowed out. 2 schools of thought there. You can be okay with that. Do you want any device that plugs into your network on the LAN side to automatically have full outbound access to the internet? Then you're pretty good here. You can add a rule that says pass, which means allow, so your actions are pass and block. And reject means reject isn't good, especially on the WAN side, because reject is the device actually responding and saying, no, you can't be allowed in there. And the thought of that is, if you're letting them know there's a device there, I just want to block it, right? Block it's like silent. It doesn't let them know there's a device there. It just, their request times out because it never gets a response. But going outbound, we want to pass all traffic. So we want to pass any traffic it sees on the LAN interface with IPv4, any protocol, from any source to any destination, and this is allow all. Oop, and then we want to go ahead and edit that, and we want to turn on logging for this and apply those changes. Now I've created a rule that says to allow any traffic from any device going to any destination, allow it. And because it's on my LAN side, it's allowing my LAN devices, in theory, out to the internet, and then you can come to your status, system logs, firewall, dynamic view, and now in your filter, you can actually put a source IP address of 192.168.1 dot, say, whatever specific device you're looking for, and you can watch all that device's traffic going out to the internet. I think we can put a filter in here. Can we? We can put a filter in 192.168.1.0. You should be able to use some filtering to, rather than pick a specific IP address, to pick the whole network. I don't have anything going outbound right now, but you start to get the idea of turning on the logging to give you greater visibility into what kind of traffic. Maybe I don't want to allow a device out to the internet. Maybe I want to block my son's Xbox One from getting access to the internet. I could come put a rule in here that says block all traffic going from a particular device to the internet, and that device would not have access to the internet. It's very important to know with rules that from a PfSense standpoint, they are processed from the top down. So even though they're not numbered, this is rule number 1, this is rule number 2. Let me bring up my pen here so you can see what the heck I'm talking about. This is rule number 1, this is 2, this is 3, this is 4. When traffic comes to PfSense, it processes these rules from the top down in order to determine if it should allow, deny, or block that traffic. If it doesn't hit a rule, then there's an unseen sort of default down here that from the LAN side is a default allow, which means if it doesn't hit any of these rules, it's going to allow it. And on the WAN side, same concept. It's going to process these rules from the top down, and if it doesn't hit anything, that's why I like having my default block all. If you want to allow something, you need to create a rule. Let's go ahead and create a new rule here. Let me show you something. Let me create a rule that says to allow pass any traffic on the WAN interface TCP that is headed to, maybe I have a FTP server. So I want to allow port 21 into my network. Allow FTP. And I want to log it so that I can troubleshoot it. By default, when I hit save here, if you look at this, it puts it below the block rule. So as traffic is coming to my firewall and processing this rules, what does it do? It hits this block rule to block everything before it gets down to the allow rule, so this wouldn't be any good. So what we need to do is drag and drop and move our allowed rules above the default block all. And then we save that and apply it. And now port 21 FTP traffic would actually be coming into my network, into the device. Same thing on the LAN side. Since we have our allow all here, you may want to block all local traffic from getting out. So instead of pass, we're going to block all traffic from getting out. This way, no traffic can get out of my network to the internet. And I want to add in specific rules. I want to allow the device on 192.168.1.100, my computer, I want to allow out. I need to make sure, again, same concept, the traffic comes to my firewall, these rules are processed from the top down. The first rule it hits that it matches is the block rule. My allow rule doesn't do any good unless I move it above the block rule. And that didn't quite get it. Let's try that again. Let's move it up, save, apply, There we go. Now, my allow outbound for this device is above the not allow everything else. So rules can get tricky. That's where the logging comes into play. You want to make sure when you're setting stuff up and getting stuff baked in, you turn on this log all packets, because then you can come to your status, system logs, firewall, dynamic view. I wish this was the default page, and actually see what's going on and see if you expect 192.168.1.100 to get out and you're getting a block here, a red X, you can actually click on it and see which rule it's triggering. Right? It's triggering a rule that you've created, and these are triggering on a lot of the default ones. But let's find one of those 23 ones, right? You can see that it says user rule block all. This rule is being triggered because it's hitting my block all. If I wanted 23 to go in, to actually work, I'd come to my hitting my block all. So think about, pretend you're the firewall and say, okay, that traffic comes in. I'm allowing 21 FTP. Well, that traffic was port 23. Oh, that's why it's not hitting. Maybe I put the wrong port. Maybe I meant to pick 23. And if it's not in the list, you do other and you type custom 2323 and hit save. Now I'm actually allowing those port 23 connections into my network. Make sense from your firewall rule standpoint? Okay. Now there's some more advanced configuration that we're not going to get into in this video of actually now taking that port 23 traffic and sending it to a specific host. That gets into NATing and port forwarding, and that'll be in a future video. But hopefully this gives you a fair bit amount to chew on with setting up your interfaces, setting up your LAN and your WAN interfaces, setting up your dashboard to give you the visibility you're looking for, and then setting up your firewall rules to allow or deny the specific traffic that you want into your network. And then coming to the systems log page, firewall, dynamic view, to actually see what's going on, what is being allowed, what isn't, and then creating your rules as such. Once you get your local network set up and all the appropriate traffic flowing in and out of your network that you want, hopefully you'll come back and check out my other videos on port forwarding and NATing, and we can also do we're going to do some virtual IPs, some NATing, and then eventually we're going to get into the VPN, the IPsec tunnels, for building a secure connection between two PfSense firewalls at two different locations. But again, hope you liked the video. PfSense.org also has some a great forum, a support forum, if you will. That was the premium portal. A great community forum that allows you to ask questions for issues you might be having, or feel free to Google if you're hitting a specific problem or challenge to be able to work around that. So hope you enjoyed the video. Thanks for watching.